Section 10.4 is polar coordinates and polar graphs. In this section, we will review the polar coordinate system and polar graphs, and we will also look at polar equations in calculus. Let's start by reviewing the polar coordinate system. Now, in a polar coordinate system, a point is represented by the ordered pair r theta. Now, we have a point in this polar coordinate system, and again, it's represented by r comma theta. Now, before I define what r is and what theta is, let's talk about two things that relate the polar coordinate system and the rectangular coordinate system. The pole in the polar coordinate system is the same as the origin, which means that this here would be considered the pole because that's the origin. Also, the polar axis is just a ray in the positive x direction, so the polar axis is just the positive side of the x-axis. Now let's define what r is and what theta is in the polar coordinate system. Given a point, r theta, we say that r equals the distance from the point to the pole. So r is going to be this distance right here from the pole to the point. Theta is the angle formed by the polar axis, remember that's just a ray in the positive x direction, and a ray from the pole to the point. In this case, theta is going to be the angle between that magenta line that I just drew and the purple line representing the polar axis. Now please note that r can be negative. If r is negative, what we do is we have a ray in the opposite direction crossing to the other side of the pole. If I wanted to draw this same point with that same angle, but having it r negative, this would be negative r comma theta, because the angle, notice, would be the same. It would be this angle, but then I would have to cross the pole to draw that distance r. Let's look at plotting different points in the polar coordinate system. Now in this given polar coordinate system, just to let you know, each one of the units away from the pole, these circles, is considered 1 unit away. These rays represent angles, and in this particular one that's given, each one of those angles is pi over 12 units. If I just write in the angles, this is pi over 12. If I add another pi over 12, this is pi over 6. And then this is pi over 4. This would be pi over 3. This is 5 pi over 12. Pi over 2. And now I'm only going to write the ones that we're used to, same ones that you see on the unit circle. We have 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, and 11 pi over 6. Now let's graph these points. When you're graphing a point in the polar coordinate system, I recommend first figure out what your angle is and then graph r. So to graph the first point, a, which is 2 comma pi over 6, the first thing I'm going to do is figure out where is the ray or where is the angle of pi over 6. Well, that's this green one that I just drew right in here. That would be an angle of pi over 6. This says I need to go 2 units away from the pole. Remember, each one of those circles is 1 unit away. This right here is point A. The next one is negative 2 pi over 6. So the only difference between letter A and letter B is that your r is negative. When r is equal to a negative number, you have to cross the pole. So you do the same thing. You first figure out which one's your angle, and then this guy would be the ray that I'm looking for. But since r is negative, you cross the pole. So you have to go on the other side of the pole. Still 2 units out. So 1 unit, 2 units right here. That would be where letter B is, or that point, negative 2 pi over 6. Notice letter C has just a negative angle. So you just draw in the negative angle first. So the negative angle, well, negative pi over 6 is the same as 11 pi over 6. This is my ray, or my angle, and then again, 2, so 1, 2 units away. Right there, that is the point 2 comma negative pi over 6. Letter D has both r and the angle negative, So you still do the exact same thing. You still want to first graph the angle. So it's the same angle you had here, but since r is negative, you have to cross the pole. This is again 2 units away. 1, 2. That would be the location for letter D. The last one that we're looking at is negative 2, 7 pi over 6. Now negative 2, 7 pi over 6 would start with an angle of 7 pi over 6. And then, since r is negative, we need to cross the pole. This would be the ray, and then r is negative, 1, 2 units. Notice it has the exact same location as point A. To recap, when you're graphing a point in polar, first determine where your angle is, and then, once you have your angle, move r units away from the pole. If r is negative, make sure that you're extending that ray for your angle to the other side of the pole to draw your point. Now, notice there's going to be a lot of different polar coordinates that represent the same point. For instance, we could have come up with other points to represent A, like 2, 11 pi over 6. In general, we say that if we have the polar coordinate point r theta, and we want a new point that represents the same place, if we want r to be the opposite, so go from one sign to another sign, you would add pi units to theta. More generally, you'd add an odd integer multiple of pi. So notice what we had up here was A and E, and A we knew was the point 2, pi over 6. E was the point negative 2, 7 pi over 6. So notice I went from 2 to negative 2, so this is opposite. And for my angle, I added an odd integer multiple of pi. Sorry, that should have been a 7. It's because pi over 6 plus pi would equal that 7 pi over 6. If you want r to remain the same, you're going to add 2 pi units to your angle. More generally, again, if you want r to remain the same, so if it's negative, it stays negative. If it's positive, it stays positive. You add an even integer multiple of pi. And we will practice finding more than one polar coordinate that represents the same point in examples 3 and 4 on the next page. Next, let's review how to convert from polar coordinates to rectangular coordinates and from rectangular coordinates to polar coordinates. If you have a point and you know that this point is r theta, and you also know that this point is xy, you can, if given r theta, figure out what x and y are, or if you're given x and y, figure out what r and theta are. Before we get to these formulas, let's explain it over here in the graph. Now, what do we know? Well, we know from polar that the distance from the pole to the point is what we call r, and that the angle I make with the positive x-axis is theta. What we know from rectangular coordinates is that x, if I bring down a perpendicular here, would be this movement here, and y would be this movement here, because I move x units along my x-axis and y units along my y-axis to get to that black dot. So this is all we know from both polar and rectangular. Now let's put it together to convert. Now, if you want to go from polar to rectangular, so you're given an r theta and you need to go to xy, again, all you know is r and theta. Well, since this is a right triangle, you know that you can use right triangle trig to solve for x and to solve for y. Well, we know that the cosine of theta is going to equal that adjacent side x over the hypotenuse r. Solving for x, we end up with x is equal to r cosine of theta. We also know that, again, if all we're given is the green, r and theta, since it's a right triangle, we can use right triangle definition for sine, saying that the sine of theta is equal to the opposite side, which is y over r. Solving for y, we would get y equals r sine of theta. So if you are given r theta, you use the formulas x equal r cosine of theta and y equal r sine of theta to convert from polar to rectangular. What about if you're given xy and you want to go to r theta? So you're going to go from rectangular to polar. So if you're going from rectangular to polar, again, there all you'd have is your x and your y. What you're going to need to do is use, again, since you have a right triangle, tangent to find theta. Why? Because the tangent of theta is opposite over adjacent. Then, if we solve for theta, we know that theta is going to equal the inverse tangent of y over x. So if you're given x and y, to find theta, you're going to do the inverse tangent of y over x. Now here you have to be really careful. When you're finding theta, you're going to need to check that the angle you get from this formula matches the quadrant your point lies in. What I mean is that if your point is in the third quadrant, the angle you should get from that formula needs to be in the third quadrant. Or if your point is in the fourth quadrant, your angle should come from that fourth quadrant. So if you're given rectangular coordinates x and y and need to find theta, theta is going to equal inverse tangent of y over x. To determine the formula for r, let's go back to this triangle here. Notice it's a right triangle, so using Pythagorean theorem, r squared equals x squared plus y squared. Therefore, we can say that r equals the square root of x squared plus y squared. So the formula we're going to use to convert from rectangular to polar is going to be r equals the square root of x squared plus y squared, and that theta equals inverse tangent of y over x. Now let's look at plotting the point in polar coordinates and then finding the corresponding rectangular coordinates for the point. Let's start by plotting. So let's plot the point -2, 2 pi over 3. If I make this bigger, we know that 2 pi over 3 is this angle right here. So there would be the angle that I'm looking at, but since r is negative, I know I need to cross the pole. I'm going to draw that ray on the other side of the pole, and I need to move 2 units away from the pole. So 1, 2, right there. That is going to be the point, -2 comma 2 pi over 3. Now I'm asked to find the corresponding rectangular coordinates for the point. What that means is that I'm given r theta and I need x and y. So I need to go from polar to rectangular. If you look here, your r is -2 and your theta is 2 pi over 3. Well, how do you convert from polar to rectangular? You use these two formulas. For x is always going to equal r cosine of theta, and for y is always going to equal r sine of theta. Plugging in the given, we would get x equals r, which is -2, times the cosine of theta, which is 2 pi over 3. Working this out, we know that the cosine of 2 pi over 3 is -1/2. So then x here would equal +1. Y would equal -2 times the sine of 2 pi over 3, because again, your r is -2 and your theta is 2 pi over 3. Working this out, we'd have the sine of 2 pi over 3 is the square root of 3 over 2, and then -2 times root 3 over 2 is negative square roots of 3. Therefore, your point is going to be 1 comma negative square roots of 3.